So let's move on to the next question, guys. In this question, we are given that there is a set A which consists of 4 distinct numbers, right? And there is another set B which consists of 5 distinct numbers. But it is also given that set B contains 5 numbers, out of which the 4 numbers are exactly the same as set A, right? Okay. We also know one more thing, that the mean of set A is equals to the mean of set B, right? We have to compare the standard deviation of A and the standard deviation of B, right? Okay. Now, this question can be solved pretty quickly, but just to explain, let's go into little detail, right? So, for example, let's say the set A contains, for example, the numbers A, comma B, comma C, comma D, right? And the mean of set A is, let's suppose, M1. The mean of set A is M1, right? Now let's talk about set B. We know for the set B, it consists of 5 distinct numbers, out of which the 4 numbers are the same as set A. So we can write 4 numbers as A, comma B, comma C, comma D, and there is one number which is different. So let's assume that number is, for example, K, right? K. Because in set B, there are 5 distinct numbers, but 4 numbers are the same like set A. I hope this should be fine. And let's suppose, and we also know that mean of set A is equals to mean of set B. So mean of set A is M1. So in this case also the mean will be what? M1. I hope this should be very, very clear, right? Okay. Now tell me one thing. What will be the mean of set A? The mean of set A will be A plus B plus C plus D divided by 4, right? So the mean of A will be the sum of all elements upon the total number of elements. So the sum of all elements will be A plus B plus C plus D divided by total 4 elements, right? This will be the mean of set A. And the mean of set A is what? Is equals to the mean of set B, right? Now what is set B mean? The set B mean will be the sum of all elements. That means A plus B plus C plus D plus K. I hope this is fine. Upon total elements is how much? 5. I hope this should be completely fine, right? Okay. Now let's solve this, right? So this becomes 5a plus, I'm solving it like this. It can be done directly, is equals to 4a plus b plus c plus d plus 4k, right? So that means if you bring it over here, so a plus b plus c plus d is equals to what? 4k. I hope this should be fine, right? I hope this should be fine. So this is what we have got, the relationship, that a plus b plus c plus d is equals to 4k, because this is 4a plus 4b plus 4c plus 4d. You bring it over here, this becomes 5a minus 4a, 5b minus 4b, 5c, simple. So this becomes a plus b plus c plus d is equals to 4k. I hope this is fine, right? Now tell me one thing. What was this? This was the mean of set A, right? A plus B plus C plus D upon 4. What is A plus B plus C plus D? It is 4k, right? So mean of set A, the mean of set A, right? This is how much? A plus B plus C plus D upon 4, right? A plus B plus C plus D upon 4. And what is A plus B plus C plus D? It is 4k. So 4k upon 4, which is k. That means the mean of set A is equals to the mean of set B. The mean of set A is equals to the mean of set B is equals to k. Are you understanding this? I hope this is clear. So the mean of set A is equals to K. And we also know the mean of set B is equals to mean of set A. So we can say what can we say? We can say from here that the mean of set A is equals to mean of set B is equals to K. And what was K? K was the fifth element in set B, right? K was the fifth element. So this was set A, this was set B. So K was the fifth element in set B, right? I hope this should be clear, right? Okay. So now tell me one thing. We have to compare standard deviation, right? So what is the formula for standard deviation? The standard deviation formula is what? It is given by root of summation of xi minus mu square upon n. I hope this is something which you are aware of, that the standard deviation is equals to the summation of xi. This is xi, right? Minus mu. Mu is what? Mu is the mean. Upon n, n is the total number of elements, right? Okay. Now tell me one thing, that the standard deviation of set A. What is set A? Set A is equals to A comma B comma C comma D, and set B is equals to A comma B comma C comma D comma K, right? And what is K? K is equals to mean. We just found out that the mean is equals to K, right? Now tell me one thing, the standard deviation of B, in the case of B, xi minus mu, right? What is xi? Xi are the different elements. For example, xi can be A, xi can be B, xi can be C, xi can be D, xi can be K, right? So xi minus mu, that means for set A. So basically for set A, you can say A minus mu, B minus mu, C minus mu, D minus mu, right? And we add all of those things. Similarly for set B, we can say A minus mu plus B minus mu plus C minus mu plus D minus mu plus K minus mu. So over here, there is one additional term which is K minus mu. I hope you understand this, right? But we also know that K is equals to mean, right? So K minus mu eventually becomes 0 because K is equals to mean. We found out that the mean of set A is equals to mean of set B is equals to K. So when you do K minus mu, because mu is nothing but mean, so K minus mu becomes 0. So what this means is that the upper part for both the standard deviation remains the same, because in this case this becomes A minus mu plus B minus mu plus C minus mu plus D minus mu square upon n is 4, right? In this case, it becomes A minus mu square plus B minus mu square plus C minus mu square plus D minus mu square plus K minus mu square. So K minus mu square is an additional term, but because we know that K is equals to mu, which is mean, so that gets cancelled. So eventually, the upper part for both the standard deviation remains the same. The only difference comes for n, because in the case of A, the n is 4, right? 4 terms. And in the case of B, n is 5 because 5 terms. So because n is 5 in case of B, right? So the denominator is greater. For B, n is 5. That means the denominator is greater. So obviously, the overall result will be small. So the standard deviation of B will be small because this denominator is greater. The standard deviation of A will be greater. Why? Because n is small, n is 4. And this part is same. Because in both the cases, the upper part remains the same, right? because k is equals to mu, so it doesn't make any difference. So the only part we have to see is the denominator. In A, the denominator is small. In B, the denominator is big. So obviously, A becomes much, much more greater than B. So that means the standard deviation of A is greater than the standard deviation of B. So your answer becomes A. I hope this should be clear. So in this case, what did we do? We firstly found out that the mean of the set A is equal to mean of set B. This was given. That is equals to K. And what is K? K is the fifth different term in set B, because all the four terms are same. Only the different term is K over here, right? And we also know that K is equals to mean. So when we find out the standard deviation, so we will do A minus mu square plus B minus mu square plus C minus mu square plus D minus mu square, exactly the same like this. There is additional term K. So plus K minus mu square. But because K is equals to mu, so this doesn't make any difference. And in this case, N is 4. In this case, N is 5. So obviously, when N is 4, this part will be greater because the denominator is small. So that is why the standard deviation of A is greater. So this part is greater than this. So the answer becomes A. I hope this should be absolutely clear.